Okay, let's unpack this. Imagine you're standing in front of some really specialized machine, maybe sophisticated farm equipment,
Right.
and you need to quickly understand its digital controls, maybe even tweak them, but you're not an engineer.
Yeah, that's a good scenario.
That's the kind of power we're really digging into today. We're talking about ISO Designer. It's this pretty powerful software from Butcher Automation AG.
And it lets you build these custom compliant interfaces
Mhm.
for virtual terminals.
Exactly.
What's really insightful, I think, is how it takes these incredibly complex industrial standards, and just distills them down into a design environment you can actually manage.
Makes it accessible.
Yeah, it makes this advanced interface creation much more accessible. It kind of bridges that gap between the complex machine and making it intuitive for the user.
That's a really crucial point. So our mission today really is to go deep into the official documentation for ISO Designer.
Right. Get the core insights.
Yeah, extract those key bits. We're not just looking at what it does, but how it actually empowers you, the user, to design these really intuitive, functional UIs for machines.
And hopefully uncover some surprising facts, maybe some practical examples along the way.
Definitely. So let's start right at the foundation. What exactly is ISO Designer?
Okay.
We're focusing on the latest advancements here. It's specifically designed for creating what they call ISO-compliant masks.
Right. For virtual terminals or VTs, think of these masks as basically the graphical user interfaces, the GUIs.
The screens you see on industrial displays.
Exactly.
Mhm.
Especially common in agriculture. And they all have to stick to this really important standard, ISO 1111083-6.
That standard sounds key. Why is it so critical?
Well, it means interfaces designed with this software. They're built to communicate seamlessly across different machines, different manufacturers even.
Ah, okay. Interoperability.
Precisely. It ensures everything, from a tractor to a sprayer can kind of speak the same language digitally. It reduces complexity out in the field.
Got it. So how do you actually build these interfaces inside the software? What does it look like?
Well, it gives you two main workspaces or editors. There's the graphic editor. That's for your visual layout where you see the interface taking shape.
Right, the drag and drop part.
Pretty much.
Yeah.
And then there's the component editor. That's where you dive deep into the details, manipulating the individual objects.
Okay, so high level and then granular control.
Yeah, that separation seems quite intentional. It really points to this object-oriented philosophy at its core.
Object-oriented, how so?
Well, everything is an object. Buttons, meters, input fields. They're all objects. And each object has properties you can edit individually.
Gives you precise control over every little element.
Exactly. So it's not just like a simple drawing tool.
No, it sounds much smarter. Like the elements understand each other, they have behaviors.
Precisely. And that raises a really interesting point, actually. How does that object-oriented approach make things like updates or modifications easier, especially with these complex UIs?
Yeah, because these VTs are often talking to a whole network of devices.
Right. And the efficiency really comes from this concept of referencing
Hmm.
existing objects.
Referencing?
Yeah. So imagine you create a standard button style.
Mm-hmm.
You can then just reference that original button elsewhere. If you need to change the style later,
Change the original.
and all the instances where it's referenced update automatically,
Yeah.
instantly.
Wow, okay. That's huge for consistency. And speed, I imagine.
Absolutely fundamental. And another really practical benefit, you can actually simulate these Butcher Automation VTs right there on your PC.
Oh, that's handy. So you can test without the actual hardware.
Exactly. Invaluable for, rapid testing, refining things before you deploy it to the real machine.
Okay, so we have this object-oriented foundation, the simulation. Let's talk about actually using it, navigating the canvas.
Right. When you first launch it, you basically get a blank slate, but it's highly customizable.
You can set it up how you like.
Yeah, you can arrange or hide different windows, different toolbars to fit how you work best.
That emphasis on a customizable, efficient UI. It suggests they really understand the designer's workflow.
I think so. The ability to tweak every detail, down to pixel coordinates or using keyboard shortcuts.
Yeah.
It's crucial for creating these precise industrial interfaces. Everything has to be just right.
Makes sense. So what are the key interface bits we need to know about?
Well, you got your standard menu bar and toolbars up top. Central access, quick shortcuts, pretty standard stuff.
Okay.
But then you have what I'd call the powerhouses, the key windows. There's the workspace window. That's for your project files.
Like a file explorer for the project.
Sort of, yeah. Then the object pool, that's central. It's where you manage all the objects you create in your project.
Everything except the main screens themselves.
Right. And then the Properties window. Whenever you select something, an object, this is where you fine-tune all its characteristics. Font, color, behavior.
Got it. And you mentioned an output window.
Yeah, that just shows you information when you build or deploy your project. Status messages, errors, things like that.
The detail here really is impressive. What would you say is maybe the single most impactful design choice that makes this efficient for a user? Is there one thing?
Hmm, that's tough. But if I had to pick, maybe it's the combination of the very specific toolbars they provide.
Okay.
It's like having this digital workbench where every tool you need for this specific job is right there. You've got the drawing toolbar, obviously, for creating objects.
Your creative tool.
Right. But then you have the align and layout toolbars. These are indispensable for getting things precise, consistent.
What can they do?
Align objects, obviously.
Yeah.
But also distribute spacing evenly commands like space across, space down, and normalizing sizes. Same width, same height, same size. Really useful stuff.
Saves a lot of manual tweaking.
Oh, yeah. Then there's the structure toolbar. This lets you group objects together into logical units called containers.
Okay.
And it also manages their display layer, what they call Z order, deciding which object appears on top of another, bring to front, send to back.
Essential for complex layouts.
Absolutely. And of course, you have zoom and navigation toolbars to move around, inspect things closely.
And you mentioned shortcuts before. For a listener, efficiency is often key when learning something new.
Definitely. And ISO Designer is packed with them. Beyond the usual Ctrl plus S for save, Throw plus C, Throw plus V for copy-paste, you get specialized ones, like Alt plus a number key can toggle specific windows like the object pool or properties window on and off.
Oh, nice. Quick access.
Yeah. And F7 to build the project, Scroll plus F5 to deploy it to the simulator or target. Things like that really speed up the iteration cycle, makes the design process much more fluid.
Crucial for getting those designs just right. Okay, let's shift gears slightly. Let's talk about actually creating the stuff, bringing ideas to life with objects.
Right. The palette of objects available is pretty rich. You start with the basics. You'd expect lines, polylines, polygons for complex filled shapes.
Rectangles, ellipses.
Ellipses, yeah, which can do circles, arcs, even pie chart segments. Rectangles have options to suppress borders, things like that. Basic built-in blocks.
But then it gets more specialized.
Oh, yes. You get into interactive elements. Buttons, for instance. They can be configured as latchable, meaning they stay pressed down, or just momentary switches.
Okay.
And buttons can have sub-objects like a graphic icon or text label inside them.
Makes sense.
And here's an interesting detail from the documentation. A button's latchable property, bit 0, cannot be changed at runtime once it's set.
Really? Why is that?
It seems like a deliberate design choice for safety or operational consistency. Once you define how that button works for a machine function, it stays that way. No accidental changes during operation.
Ah, okay. That makes perfect sense in an industrial context. High-stakes environment. What else is in the toolbox?
Lots. There's something called an object pointer. It's a powerful concept. It's an object that can reference or point to other objects.
Right on.
And its appearance changes at runtime based on which object it's currently pointing to. Very dynamic.
Okay, interesting. And inputs, outputs.
Full suite. Input Boolean, like a checkbox for true false. Input number for integers or floats. Input string for text. Input list for picking from a predefined list.
And corresponding outputs.
Yep, output string, output number, output list objects just for displaying data. Then you have soft keys.
What are those?
They're specific buttons designed for dedicated soft key masks, usually arranged along the edges of the VT screen. Common control layout.
Got it. What about visualizing data?
Good options there too. Linear bar graphs, horizontal or vertical fills, arched bar graphs for curved displays, and meters, like a classic tachometer with the needle and tick marks. Visually engaging ways to show levels, values.
Sounds comprehensive. Any really specialized object?
Definitely. Container we mentioned for grouping. Macro objects, which we'll get to, for running command sequences. Graphics context is cool. It allows for dynamic drawing on the VT itself.
Like what?
The example given is drawing the swath paths behind a moving tractor directly onto the display.
Wow, okay. Real-time visualization.
Yeah. There's also color map for changing the whole color scheme on the fly. Picture graphic for images, PNG support came in version 5.1 if you target VT level 6.
Good to know.
Scaled graphic for dynamic image resizing, animation objects for showing image sequences, and importantly, auxiliary input and auxiliary function objects.
What are they for?
Integrating external controls, joysticks, rotary encoders, things like that. Again, directly referencing that ISO 11148336 standard for how those devices communicate. The breadth is really impressive.
It really is. Now, how do you control the look and feel of all these objects?
That comes down to attributes. Things like font attributes, line attributes, fill attributes, input attributes. They define the visual style and, for inputs, the interaction properties.
Okay.
And crucially, these attributes can be defined once in the object pool and then shared, reused across many different objects.
Back to that consistency point. Define it once, use it everywhere.
Exactly. Ensures a consistent look and feel throughout your interface.
This leads nicely into copying objects. You mentioned referencing before, but are there other ways?
Yes, ISO Designer gives you really smart copying options, these copier modi. When you copy an object, you choose how it's done.
Okay, what are the choices?
You can do a deep copy. That creates a completely new, independent object, including copies of all its sub-objects. It's totally separate from the original.
So if you want to make unique changes just to this one copy.
Right. Or you can insert a reference. This is what we talked about. It just creates a link back to the existing original object, change the original, and this reference updates too.
The efficiency option.
Definitely. Then there's insert a first-level copy. This is sort of a hybrid. It creates a new main object, but it references the existing sub-objects from the original.
Okay. A bit more nuanced.
Yeah. And finally, there's advanced copy, which gives you really granular control over exactly which parts are copied fresh and which parts are referenced.
So it's like choosing between making a completely unique copy, a totally new thing, or just creating a shortcut back to the original. That sounds super practical.
That's a great way to put it, yeah. That distinction between deep copy and referencing is critical. It really tackles that challenge of managing complexity in these big industrial applications, allows for both unique tweaks and system-wide consistency.
Okay, let's move into the really dynamic part, making the interface intelligent with events and macros.
Right. So events are basically the triggers. They're specific things that happen that can set off actions.
What kind of things? User actions?
Yeah, user interactions are a big part, like an on-key press event when a button is physically pressed down, or on-key release when it's let go.
Okay.
But events can also be system changes, like on-change value when a number or a text string being monitored changes its value, or on-show when a particular screen, a mask, or even a container object becomes visible.
And on hide when it disappears.
Exactly. It's quite a rich set of triggers that let the interface react to almost anything happening, user-driven or system-driven.
Very dynamic. And when one of these events happens, it triggers a macro.
That's the idea. Macros are sequences of commands that get executed when they're linked event fires.
So event happens, macro runs, commands execute.
You got it. And these commands are what let you dynamically control the UI. They're like little mini programs that change things on the screen.
What kind of commands are we talking about?
Well, stepping back, they're quite powerful. You have commands like show hide object to make things appear or disappear dynamically.
Changing the interface layout on the fly.
Right. Change numeric value and change string value let you update the data shown in output fields.
Okay.
Change attribute is interesting and lets you modify object properties at runtime. So you could say change the number of tick marks on a meter object based on some condition.
Wow, okay. Very flexible.
Yeah. You can also navigate between screens using change active mask or change soft key mask, and even control sound with control audio device and set audio volume for auditory feedback.
Let's make this concrete. Can we walk through that tractor and sprayer example?
Sure. It's a good practical illustration.
Yeah.
So first, you'd set up your main screen, your data mask. You'd draw the tractor and its sprayer using basic shapes, rectangles, ellipses, polygons.
Just the static visuals first.
Right. Then, the interactive part, you'd create a container object. Maybe draw the sprayer's spray jet inside that container.
Okay, so the spray itself is grouped in a container.
Exactly. Now for the controls, you'd create a separate soft key mask and put two soft keys on it. One labeled maybe key sprayer off, the other key sprayer on.
Simple on-off buttons.
Yep. And here's where events and macros connect. For the key sprayer off button, you'd link its on-key press event to a macro.
And that macro.
That macro would contain just one command. Show hide object, configured to hide the container object that holds the spray jet graphic.
Okay. Press off, the spray disappears.
Right. And conversely, the on-key press event for the key sprayer on button would link to a different macro.
Which uses show hide object to show the spray jet container.
Exactly. So a simple button press triggers this sequence. Event fires, Macro runs, command executes, visual change happens. You actually see the sprayer turn on or off on the screen.
That really brings it to life. A simple button press triggering a visual cascade showing the machine's state.
And that practical example really highlights the power here. It's event-driven programming, but within a visual design tool. It lets you build these responsive, intuitive UIs where complex machine states are communicated clearly and instantly to the operator.
It's a testament to how you can apply this knowledge to make something truly functional.
Absolutely.
Okay, so we've got objects, events, macros. How do you manage all this complexity when you're working on a big project? Let's talk project management and advanced features.
Right. Well, ISO Designer uses a clear hierarchy. At the top, you have a workspace. A workspace contains one or more projects.
And each project holds its own masks, objects, files.
Exactly. You can create new workspaces and projects, open existing ones, rename them easily. Pretty standard stuff, but crucial for organization, especially if you're working in a team or on multiple related systems.
Keeps things tidy.
Definitely prevents chaos. Now, central to managing the contents of a project is the object pool we mentioned earlier.
The repository for all the objects.
Yeah. Everything except the main masks themselves lives here. It's presented kind of like a file explorer, categorized by object type buttons, inputs, graphics, attributes, macros.
And everything has a unique ID and name.
Yes. And it's more than just storage. It has built-in functions. You can search for objects easily. There's a function to find unreferenced objects.
What are those?
Objects that you've created and are still in the pool but aren't actually being used anywhere on any mask at the moment. Helps you clean up clutter.
Oh, that's useful.
Yeah. You can also pin important objects to prevent them from being accidentally deleted.
Right.
There's a compress function.
What does that do?
It scans your project for identical attributes, like, say, multiple font attributes that are exactly the same, and consolidates them into one shared instance. Keeps the project file lean and efficient.
Smart. Now, you mentioned something even more powerful for reusability, the library manager.
Ah, yes. The library manager. This is a prime example of promoting modular design and reuse. Really vital for scaling up development or keeping designs consistent across a whole product line.
So this is where that critical thinking about long-term efficiency comes in.
Absolutely. The library manager lets you store and reuse objects, masks, main objects, sub-objects, macros, variables, attributes completely independently of any single project.
So if I design, say, the perfect spree nozzle graphic in one project,
You can save just that graphic or a group of related objects to a library file that use a .jlib extension.
and then I can just pull it into any future project I work on.
Exactly. You can import and export entire libraries. You can just drag and drop objects between your current project's object pool and an open library. You can even add external graphics directly to a library.
Wow. Okay, that sounds like a massive time saver, a real game changer for efficiency.
It really is. It encourages building up these reusable components.
Beyond the core tools, how much can you customize the environment itself?
Quite a bit, actually. There are options and customized dialogues. You can tailor general settings like where your projects are saved by default or how image files are handled when imported.
Okay.
You can fine-tune the editor's behavior, things like autosave settings, what happens after a build or deploy. You can even, thankfully, disable those persistent "don't show this dialogue again" pop-ups if they annoy you.
Ah, yes, those can be disruptive.
Right. And workspace preferences too, like setting up auto-recover options. And significantly, you can choose to save the project files, which are XML-based, in a formatted way.
Why is that significant?
It makes them much easier to use with version control systems like Git. You can actually see the differences between versions clearly. Huge for team collaboration.
Ah, good point.
Okay.
Any other customizations?
Yeah, you can customize the visual grid, the layout guides, things like that. Really tailor the workspace to your preferences.
And what about different languages? If you're building interfaces for a global market.
That's covered too. ISO Designer supports multilingual resource IDs,
Meaning?
meaning you can associate different text strings in different languages with the same ID. Then, depending on the language selected on the VT, the correct text appears automatically. Makes translation and localization much easier.
That's not just a nice to have, that's pretty critical for real-world application.
Definitely. Essential for global markets.
You know, this whole deep dive, it really shows how a piece of software that might seem quite niche at first glance is actually built with incredible foresight, packed with powerful, very specific tools designed for complex tasks.
Indeed. I think it demonstrates that often the most valuable knowledge isn't just the broad overview, but understanding these granular capabilities. the details that allow for precise control and truly adaptable solutions in these demanding contexts.
So just to recap, we've journeyed through understanding what ISO Designer is, its object-oriented core,
Navigating that customizable environment, the toolbars, the windows,
creating all those different objects, from basic shapes to complex meters and dynamic graphics,
bringing them to life with events and macros, making the interface responsive.
and then managing it all efficiently with projects, the object pool, and especially those powerful libraries for reuse.
Quite a comprehensive tool set.
It really is. So here's a final thought to leave everyone with. Consider how software like this, ISO Designer, which is built for such precise control and very specific industrial applications,
Hmm.
how might that inform what we expect from, say, general user interface design, for our everyday apps and devices?
That's an interesting question. If complex machinery can have these carefully crafted, dynamic, often quite intuitive digital interfaces.
Right. What does that imply about the potential we maybe haven't tapped into yet for intuitive control in our smartphones, our smart homes, our regular digital experiences?
Are there fundamental principles of design, of interaction, that we could learn from this world of ISO-compliant virtual terminals? Principles about clarity, responsiveness, managing complexity.
Exactly. What could we adapt from a system designed to safely control a giant tractor?
That
To make, I don't know, setting our thermostat better, something to mull over.